Perfect. Good morning and good afternoon. We're here for another episode of Coffee and Compressed Air with Dr. Elvira Rakova and myself.
Good
Um,
evening also from European side here.
yes, a lot of people don't know. So you are in Italy and I am in Northwest Indiana, but very close to Chicago. A lot of people don't really know in the Indiana so much, globally at least. So I wanted to kind of step back a little bit because, of course, it's December, everyone's reflecting. But I was going through my LinkedIn and I have probably about 3,000 safety managers connections out of 5,000 people that I'm connected with. And I'm like, okay, let me step back and because I used to share a lot of information on noise reduction, OSHA compliancy, safety, quality, things like that related to compressed air. And then I'm like, okay, what can I do for this big group of people that I have? And a lot of my conversations back then, over 10 years, were always letting them know what is actually on the floor because they know the regulations, they know the rules, they know how to calculate noise levels from various different points. Um, so they're very well versed in that. But when new or even safety managers come into the plant, a lot of times, maintenance or engineers or someone doesn't take the time to walk them through the entire process or what they have. So I kind of wanted to do an episode today for even the quality managers because I used to work in quality even before compressed air, and you're inspecting, the physical products, but if you don't know the whole process and where different things can happen, so where you're inspecting this end product and you're like, okay, why is there oil on it? Like, where did that come from? And then you kind of have to reverse figure out where this different things are coming from. So here, and of course, we have Dr. Elvira Rakova, who can very easily give us the layout, and you're a professor also. So I think this is a great overview for people who are walking on the plant floor, kind of what they can expect from different parts, and then we can add in maybe some safety issues or quality issues that they can connect some dots when they're sitting in these meetings about, and then someone mentions PSI or compressed air cylinders or something.
Yeah, not a professor, guest lecturer.
Yes,
So
thank you.
important note. but
Important.
anyways, I can talk a lot about compressed air. Of course, I'm not a quality engineer, quality expert,
Mhm.
but I think it's a good, as you told me, to give a little bit an overview what compressed air system is in terms of what are the quality issues can be connected to that, not only quality issues but also sustainability issues, because I
Mhm.
know that some quality engineers, depending on the size of the facility, they also can be the sustainability engineer or ESG as it's called,
Mhm.
like depending also where you are. I actually today I have also a few slides to share just to give a little overview for that, and I'm going to share it right now. Just to start right away on where we stand in terms of the compressed air system. So let me start sharing my screen, and we are sorry here. Do you see now my presentation, my screen?
Yes.
So the compressed air, as we always say, is do you see now as a presenter mode or the full screen? Should I
Yeah,
switch
yeah,
my
we see
display?
presenter. Yeah, we see presenter mode.
Okay, let me just swap the screen. So basically, when we look at the optimization of compressed air is the veins of the industry. So it is the source of a mechanical energy in your plant, meaning whenever you have something at the end of the process, something is stamping, putting the color. So it is the spraying, or it is, for example, cleaning or cooling or any other end uses. You have a compressor room few meters from that or few maybe kilometers, depending what type of plant you have. And basically, when we even work on the compressed air system reduction, of course, it is a cost. A lot of people, like some people say, like not about Paul actually say from compressed air consultant, like it's not about the air, it's about the money, and I completely agree on that. And we can actually get into the holistic picture of that. So if we talk about the cost reduction, it's very obvious. It's energy cost that is interesting for energy managers. It's a downtime cost. Downtime of the one machine costs a lot, especially if we're in food and beverage, in the metal production. So, and the maintenance cost, of course, it is your personal cost. So it's everything connected to the money part. But when we look at the product quality, it is the first one, of course, it is the defective products that we have. In automotive industry, there is a requirement for a certain pressure level for the spraying, for the applications, coloring them. If we have the spraying applications, like the painting of the carcass of the car. And I visited the facilities. 6.5 bar was required, so it's like about 80 psi, I think. And then if it was a small drop of the pressure, even 0.1 bar or like 10 psi, it was already the defective product. And the problem was actually in the compressed air, in the distribution of the compressed air. So it was clogged filters that were causing this higher pressure drop, resulting in the whole defected product of the carcass of the car, resulted then into the maintenance cost and the downtime cost, because operators had to find what was actually the problem. So, and this is, I think, for the product quality. And whenever you have any cleaning, you have not a good cleaning product, you don't have enough mechanical force. There are not enough force for pressing, for example, so the mold is not coming the correct way. It impacts a lot. So I always recommend to work in general, not to start even with the compressor room and the optimization, but start with the process. And don't go into the change in the process, but rather analyzing, is the process runs correctly here? Are operators of the machine happy with the blowing forces there? Are they happy with the quality of the product that comes out? And usually there is, of course, the full quality team that can see what are the mediums are involved, type of gases, compressed air, it is electric drive are involved, what type of the mechanical motions are involved in this, in order to perform this product quality. And once you start to look into that, you easily go into the full compressed air design. Of course, when we speak about the product quality, we have also now a new standards. I need to check if it is only in Europe or it's becoming now also more international. It is the eco design standard. So it's a new eco design standard where you have to analyze all parts that are involved into the design of the mechanical part. So I know I reviewed also the standard, saw the standard for the eco design. And there is always the analysis of how much energy is used in order to produce this product. And since compressed air is usually used a lot and it's quite expensive, and in general, it has also the impact, the CO2 impact on that, reducing the energy consumption can impact also to have a higher eco-design label, meaning that you have a lower CO2 emission. And here we are going into the reduction of the CO2 impact on the environmental part. By having actually environment, it's extremely important, and this is why I do my work actually in the first place. But you also can make money on that if you have the higher eco-design standard together for your product. So this is extremely important, and this analysis can be done really, really good. And then when we connect it with the safety and security, and this is, Danny, it's your moment. So I here always talk about of course, the noise reduction, especially for the blowing application. And if you have, if you need information about this, about the OSHA requirements or in general, so Danny worked in this for the past 10 years and has a lot of post information. So please also reach out to her. And safety measures for the operators extremely important. Pneumatics is used in many safety operations, many safety circuits. Even like the simple one when you need to have two hands to press two buttons, not in order not that operator doesn't like be that his fingers will be cut off. I mean, God forbid, but this is like something that has happened that can happen. So there are safety circuits, safety doors, a lot of safety circuits. There is a full standard with the various steps that should be followed for the pneumatic applications, and it's extremely important medium for the safety circuits. So, of course, if you have problems in the pressure drop, something's happening with the flow, something is happening on the side of the product quality, for example, in the air quality, in the filters, in the dryers, it extremely impacts this. So it's compressed air is not just for the sake of compressed air to have a nice shiny compressor room. At the end, it is a base for everything from safety and security to the product quality. And of course, if you manage it badly, then you have problems. But if you actually can take care of your compressed air system, you'll see an enormous impact into all other areas. And I think this is fascinating. Whenever you start to work on the product quality, you will see reduction in energy cost.
Yes.
If you work on the energy cost reduction, you see the product quality improvement. And the same thing also for safety. I have here a very short example. So it's kind of like all the use case, but I really like it because we gathered the data with the user and analyzed a lot of things. In terms of the product, the product here was small, like a mechanical part for the automotive industry. And here is basically, we see the reduction in cost was enormous reduction of 60%. Maintenance cost also about 20% from the energy cost, and the accident insurance cost. So it was in Italy, and we could really nicely analyze it. And of course, the part of the value proposition of this company was the lower carbon input of the products, and the carbon input was calculated in connection with the kilowatt. You can also calculate it. We used the new design for that when we created the new design of the system, how the air was used, and then improved product quality and consistency. So this was extremely important because it is a high precision mechanical part for the automotive industry, and the quality, the tolerances were there extremely important. So we had to look at the air quality, the pressure levels and flows that were in the facility. Also temperatures. This was also very interesting what we had to look. So they reduced injury risk because there were also a lot of blow-in application operators actually were not wearing glasses. There was a lot high risk of that, high noise, and of course it became then compliant with a lot of regulations that had to be followed. We don't put the name of the company, but in general, what I find fascinating here with so many benefits, the project was realized in 14 months. The payback, sorry, the project was realized like in 1 year, but the payback period was 14 months. 1 year in 1 year and 2 months, it paid back to improve that. So I don't know. I still don't know why people don't just say, hey, let's do only compressed air. And if you're new to this industry, so just to if you're new to this topic, I mean, and you work in the facility or safety manager, you for sure have if it is a production facility, you have compressed air. Probably. So I can share also later some types of industry that consumes compressed air in the various like ratios. So it's quite interesting. And in total, we take the industrial consumption, it's about 20% of from the industrial consumption is compressed air. And where it will be used, so we call it working air automation. If you in automotive industry, food and beverage, woodworking, automation space, so anywhere where you have the automation moving parts, you probably don't have everything electrified there. And I actually have a post today about the electrification topic, and it's everywhere that you have moving, stamping, you hear air, and you hear the air exhaust, and here it is used. We call it working air because there the energy of air is transformed sort of mechanical work there. Painting application that I said before, application ATEX. ATEX is where we have the high explosive environment, so it's in the mining industry. You can find it also in other industry where this requires some construction, very applications also for mobile applications and so on. Active air, where we have the material transport, for example, would be the cement industry, bearings also. Process air is the most in the process industry, petrochemicals, for example, where we have the dryers, also ventilation, it's also air with the lower pressure levels, fermentation processes. So again, all types of the bioproducts and biofuels. Vacuum generation is the separate part. More and more applications, but just to give you also a flavor of that. And when we look at them, nowadays, of course, you can find a lot of audits and it's maintenance, but 70% from all this 100% of possible energy savings usually are found in the design. And it's simply because the system were never, ever considered to be efficient. So they just grow together at some moment, and it's not just as a one component, it's a very complex system. Why is complex? And when we look at the quality in the safety part, we always look at the end production, right? So we look here in the I want to have the laser pointer, but we look into the utilization part, right? This is the final, where the final process is happening. This is what for quality engineer is interesting. You go into the machine, you see the final product is going out, and then you see what's wrong with this, what process, what mechanical action caused this problem in the quality. And here, this is basically what is interesting for us. But in order that air arrives to this, we have a distribution part, and this is oversimplified, of course. And then we have a compressor room also. When we see the standard approaches here in the audit industry, it focuses only on compressed air for the compressed air. So meaning that we're going on the generation part, maybe just few point of uses, but to see how to optimize compressor, what is extremely important. But we focus here only, I would say this is most interesting for the utility manager, that you have a certain flow and pressure that goes there. And here is already what is very important for the safety and for the quality managers, what arrives here, what quality of air, at what pressure it arrives, and what flow you have there. Do you have some downtimes here, and so on. So this is why it's extremely important always to start the analysis from the process, where the air is used. And this is why I really love to work with the operators and the quality managers, because you ask, are you happy with the quality of the product? The first thing. So are you happy with the quantity of the product that is coming out? If you're not happy, let's take a look. Maybe we can improve the process related to, of course, to the compressed air, and maybe we can do something else. And it's not only the blowing, it can be the cycles of the stamping of some stamps, for example. So it can be also the bottles quality. So a lot of things, the filling of the bottle, time. This is also, so the quality and quantity is extremely connected. So once you start to look at this, you will be fascinated in how many processes you will see the compressed air. So it's not just something that is blowing, it's also everything that is moving there. So this is why it's very important. And
well, and I want to add in real quick in
yes,
the utilization, because that's where I spent most of my time, and that's where the people are. So that's where the operators are. So they're going to be exposed to the most hazards there,
yes,
because they're going to be around these moving parts. They are holding blowguns. They are exposed to the air blowing, to dust, particles, everything. And when that part is not optimized as far as the compressed air system, so if they don't have the right tools, if it's not working properly, the operators have to meet a certain output, right? So they end up taking matters into their own hands, which is not always the safest design wise. And so there you get a lot of rigged, tools, guns that can either cost more money, do more damage, but they're getting the result that they need in order to get the products out.
exactly. And I think this is just like a very very small, like small steps for the optimization. It is of course, the monitor the product, the reduce, check the analyze the system, so integrate efficient technologies, and I'm going to start sharing at this moment. And this is basically only just the steps to start with, but just to start with is go into your machine, talk with the operators, and see where the air is used. Operators always know, and they always can tell you, are they happy with the quality, are they happy with the end product. Very often we see, for example, there is an energy manager buys a new component, a new equipment, it is installed, but then operators are not happy and they remove this equipment, they remove like nozzles, they remove like a lot of things. So they say never reduce the pressure. I have here the cylinder is like super important part. And it is also for him what it's at the end, you need the compressed air for the use of this compressed air for the mechanical work. You don't need compressed air for the sake of compressed air. And I see very often there are systems, that monitoring system, that reduce the pressure level for the machine until the operator comes screaming and telling what's going on. And then they have a fight with the utility manager, and then the system is removed. Just because some company decided to create amazing system that that reduce the pressure, because reducing the pressure reduce also the energy bill. Yeah, but but you need to know always the optimal pressure level for this. And by reducing pressure level, it's not so trivial. So sometimes maybe you can, if you want to reduce the pressure level, you need to see what is the critical application. And if there is a cylinder is a critical application, you can put even an electric drive there. It will maybe worth it. So you put one electric drive that is more expensive, but then you can reduce the pressure level and save, I know, 7% of energy bill, but not just like blindly start reducing it and wait until someone like comes and say I'm not happy. So this is why this is where I see like a lot of not a conflicts, but I would say like a frictions in the facilities, especially energy managers and operators, because they've been through this kind of system installations, and like their work depends on that.
Yes.
And for the quality managers, like they need a quality product. They don't care about compressed air or the energy bill of compressed air.
Right. Yeah, and it's exactly the same. It's exactly the same for safety managers. They have their criteria they need to meet, and the operators have theirs. And just like you said, they implement tools, like, so they'll only look at the noise level of a tool without looking at the design and the actual use of it, trying to meet their requirements. So the design is extremely important of these systems, but they're not, they shouldn't be expected to be compressed air experts. I think this is where some of these calculators come into play here, is for these type of people who work adjacent to the compressed air, and they have certain needs of it as far as quality, safety, and energy, but they're not in the actual operations, like with the output of it. So they all need to work together. So I will make sure to put a link to that in the comments. And if there are any safety, quality, energy managers, we're happy to have a conversation to assist. I know, especially for all the safety projects that I did, we always ended up working with engineers because you need to justify. So yes, even though it's safety and we should save everybody's hearing so they can hear their grandkids one day, operations doesn't really work like that. So there are different ways to justify a lot of these savings that can benefit, like you said, reducing the noise can optimize output, optimizing this can optimize output. So they can all work together if done the right way. So I want to leave it probably there with that message. So at least give some hope to some safety and quality managers who desperately need to meet new standards for next year. And hopefully we can help with that. Perfect. And we are at 24 minutes. So we are going to cut this one off, and you all know how to reach us. We will see you next week. Thank you.
Thank you.